Welcome to This Explainer. Today, we're unpacking a truly wild medical story. We are tracing the historical evolution of peptic ulcer disease. Now, this isn't just some dry timeline of medical facts. It's actually a fascinating saga about stubborn dogmas, radical self-experimentation, and how scientific breakthroughs can completely rewrite everything we thought we knew about the human body. Honestly, if you want to understand how medical truth evolves over time, this is the perfect case study. We're grounding this entire explainer in a fantastic, peer-reviewed deep dive by lead author Marcelo Garcia Toneto and his colleagues. What's so great about Toneto's research is how meticulously it documents this crazy journey. We'll be using their findings directly to see exactly how the medical establishment went from surgically removing entire organs to prescribing simple pills and eventually to just handing out antibiotics. Here's our roadmap for today. We'll start with the introduction and acid hypothesis, move into the era of surgical dominance, trace the anatomical evolution of vagotomy, look at the pharmacological transition, dive into the bacterial paradigm shift, and wrap up with the Nobel laureates in gastroenterology. Let's get right into it. Section 1. Introduction and acid hypothesis. To really understand this, we have to start our timeline way back in 1822. An American Army surgeon named William Beaumont was treating a patient who had actually survived a gunshot wound to the abdomen. The wound healed into a permanent fistula, which was basically a literal window directly into the man's stomach. Beaumont used this incredible, albeit bizarre, opportunity to isolate hydrochloric acid in human gastric juice, proving once and for all that digestion was a chemical process. That single discovery set the stage for Carl Schwartz in 1910, the massive pharmacological boom of the 1970s, and the shocking bacterial discoveries of the 1980s. So, jump to 1910. Carl Schwartz coins a phrase that will become undisputed medical dogma for over half a century. No acid, no ulcer. And it made sense, right? Because over 90% of ulcer patients showed signs of high stomach acid. The entire medical establishment fixated on one singular goal. You have to eliminate the acid. But without effective drugs, how do you actually do that? Well, at the time, you had to cut. Which brings us to Section 2, the era of surgical dominance. Think of the early surgical approaches as, well, extreme mechanical plumbing. Surgeons performed procedures like the early gastrojejunostomy. The whole idea was to bypass the ulcerated areas by connecting the stomach directly to the jejunum, the middle part of the small intestine, without actually removing any part of the stomach. But there was a massive flaw here. The stomach was still churning out acid, and now that acid just poured directly into this brand new surgical connection. As a result, patients suffered a terribly high rate of new ulcers right at the surgical site. So surgeons had to adapt. Prominent figures like Braun and Roux continuously tweaked the plumbing to try and prevent the stomach acid from pooling and destroying the intestinal walls. But despite their absolute surgical brilliance, bypassing the problems simply wasn't enough. The failure rates and the postoperative complications just remained frustratingly high. This frustration led to the rise of the gastrectomy. The logic shifted. If the stomach is making too much acid, let's just remove the parts of the stomach that make it. Pioneered by figures like Theodore Billroth, surgeons began aggressively resecting the lower parts of the stomach. And honestly, it worked. The recurrence of ulcers plummeted to around 3%. But think about the incredible cost to the patient. They had to endure profound, permanent anatomical alterations. It led to severe long-term side effects and a drastically reduced quality of life. The cure was almost as brutal as the disease itself. Section 3. Anatomical evolution of vagotomy. Eventually, doctors realized there had to be a smarter way than brute force organ removal. And to understand this next leap, we have to look at the nervous system. A vagotomy is the surgical severing of the vagus nerve. Early physiological studies, notably by Ivan Pavlov, the guy with the ringing bell on the dogs, proved that the vagus nerve controls the cephalic phase of digestion. Basically, when your brain anticipates food, it sends a signal down the vagus nerve telling your stomach to pump out acid. Surgeons figured out that if they just cut this communication line, they could turn off the acid tap without having to remove the stomach itself. This is where Lester Dragstedt steps in during the 1940s. Dragstedt is a fascinating guy because he was actually a highly trained physiologist who later became a surgeon. He brought that deep physiological understanding right into the operating room. He introduced the truncal vagotomy. By severing the main trunks of the vagus nerve and combining it with a pylooplasty to help the stomach drain, he tackled the problem at a neurological level. But science always refines itself. By the 1960s and 70s, the surgical thinking was, why cut the main power line to the entire house if you only want to turn off one specific light switch? This logic led to the proximal gastric vagotomy, or the highly selective vagotomy. Instead of cutting the main trunk, surgeons meticulously targeted only the tiny nerve branches feeding the acid-producing parietal cells, specifically the nerves of Latarjet, while leaving everything else perfectly intact. The results of this highly selective procedure were literally staggering. Introduced by Hawley and Hart in 1967 and refined by Johnston and Amdrup in 1969, this technique totally eliminated the need for a secondary stomach drainage procedure. Across 5,000 documented cases, it achieved a remarkably low 0.34% mortality rate and only a 5% recurrence rate. This was it. This was the absolute pinnacle of surgical management for peptic ulcers. Surgery had basically been perfected. But just as it reached perfection, it was about to become entirely obsolete. Section 4, the pharmacological transition. In 1972, a massive, game-changing breakthrough occurred. Sir James Black discovered histamine H2 receptors in the stomach's parietal cells. He realized that histamine was a massive driver of acid production. So by developing a substance to block these specific receptors, he created zimididine, the very first highly effective targeted acid-blocking drug. Suddenly, you didn't need to surgically sever nerves to stop acid. You could literally just give the patient a pill that chemically blocked the receptors. And the advancements snowballed incredibly fast from there. Following Black's work, George Sachs discovered the actual mechanism pumping out the acid, the proton pump in the stomach lining. This led straight to the presentation of a new drug, omeprazole, at the 1982 World Congress of Gastroenterology. These proton pump inhibitors provided far more profound and long-lasting acid suppression than anything before them. Virtually overnight, pharmacological acid suppression became the absolute gold standard treatment, and the once glorious era of ulcer surgery just quietly faded away. Section 5, the bacterial paradigm shift. Now, this is arguably the most disruptive paradigm shift in modern medical history. Remember Karl Schwarz's no acid, no ulcer? Well, in the 1980s, two Australian researchers, Robin Warren and Barry Marshall, noticed something super peculiar. They kept finding a curved, gram-negative bacterium in the stomachs of ulcer patients. Today, we know it as Helicobacter pylori. Finding this completely shattered a foundational academic dogma. Up until this point, every medical textbook stated as absolute fact that the human stomach, full of flesh-eating hydrochloric acid, was completely sterile. Yet, here was H. pylori happily colonizing the stomach. When Marshall and Warren proposed that these bacteria were actually causing the ulcers, the scientific community literally laughed them out of the room. The skepticism was intense. So, to prove Koch's postulates, the strict scientific rules for establishing that a microbe causes a disease, Dr. Barry Marshall took a radical, incredible step. He brewed a broth containing a massive dose of H. pylori and he drank it himself. Just over a week later, endoscopes confirmed he had developed acute gastritis. He used his own body to definitively prove that a bacterium, not just stressor acid alone, was the root cause of peptic ulcers. And the best part? It meant ulcers could actually be cured with simple antibiotics. Section 6. Nobel laureates in gastroenterology. This entire historical progression is perfectly validated by 3 monumental Nobel Prizes. Think about how this maps onto everything we've just covered. First, Ivan Pavlov wins in 1904 for understanding the physiology of digestion, laying the groundwork for those vagotomy surgeries. Decades later, Sir James Black wins in 1988 for giving us H2 blockers, ushering in the whole pharmacological era. And finally, Barry Marshall and Robin Warren win the Nobel Prize in 2005 for discovering H. pylori, turning an incurable, surgically intensive disease into something you can clear up with a week of antibiotics. That is 3 completely different scientific approaches to the exact same disease, all worthy of a Nobel Prize. Which leaves us with this final thought. Think back to the thousands of brilliant surgeons who spent their entire careers perfecting the highly selective vagotomy, totally convinced they had found the ultimate cure. How rapidly can definitive established certainties be rendered entirely obsolete by methodologically sound scientific research? The history of peptic ulcer disease is a brilliant warning and a true testament to the power of scientific innovation. It reminds us that in medicine, today's absolute truth might just be tomorrow's historical footnote. Thank you so much for joining me on this explainer. Keep asking questions and never stop learning.